Hi, everyone. Hope you're having a great day. This is our final presentation for our thesis project, Smart Water iBottle, Your Health Body, designed and implemented by Hassan, Mariam, Mohamed Shenawy, Salma, and me, under the supervision of Dr. Mohamed Shalan. I have the control. Okay, so this is the outline for our presentation. We're going to walk you in through the problem, motivation, solution. Then we're going to talk about the system features and the system architecture. We're going to state also our development methodology and walk you in details through the system design. Then we're going to talk about the product demo, capstone, reinforcement outcome, final outcome, and the references. Okay, so our problem is there are so many people who struggle in achieving the optimal daily water intake, which affects their performance in general, and it can also affect their health later on. Another problem that we face is that we should be less dependent on plastic water bottles to decrease our plastic waste, and that's why we came up with our solution, which tackles both of these problems. So iBottle is a smart water bottle that tracks your daily water intake. It also sends you notification through an application which we will explain later on in details. And it also decreases your dependence on plastic bottles. Now Shenawy will take over.
Thank you, Eman. So what really motivated us in creating this water bottle is that it's a new and innovative research area. There is no common products in the market. I mean, like many more products. And then we enhance our users' lifestyles and we promote sustainability. So we kind of give back to the community. And what are the product features that we offer in the iBottle? First of all, we connected the bottle to the smartphone, and we track water intake. So like the bottle tracks every sip you take, and we measure the water temperature. We give also periodic reminders for the users to remind them that they still haven't reached their goals and they should take the drink water right now. We offer Find My Bottle in case the users lose their bottle somewhere. So we navigate them to the last paired location. We also have the goal tracker to display monthly statistics and also weekly statistics. We have an interactive map to show the like selected water dispensers. We only did this in the scale of AUC right now, but it's supposed to be on a bigger scale later. And everything reflects on the app: the water temperature, the volume, the current goal, the progress, and everything. And we can share with friends. You can see your friends and families water progress and celebrate together if you reach your goals. For the system architecture, we need to use a cloud and a backend server database so that we store the users' data in case they change their phones, they wanted to connect connect from a new phone. Also, if they wanted to look at their friends' data, that's why we needed to store the data on a cloud. And of course, the mobile phones connect to the cloud using the internet, and the smart buttons connect to the smartphone using Bluetooth BLE. And now Mariam will take over.
For our development methodology, we followed the agile method to produce shorter development cycles and more frequent product releases. And we had 5 sprints that we started on the 25th of September 2021 until our 5th sprint that we finished on the 12th of May 2022. This is compared to we use the agile than the traditional waterfall method. For our system design, our hardware part, We started first using the STM32 microcontroller, but the problems that we faced that it didn't have a Bluetooth and the built-in sensors, so which led us to have extra connections and it costed us more. So we found an alternative, the Arduino Nano 33 BLE, that included the BLE module, but it didn't include the built-in sensors. But so the problem that we faced with this microcontroller that it needed extra circuitry and it costed us more. So we found the Arduino Nano 33 BLE Sense that included both the BLE module and the built-in sensors. So it had both, so it was perfect for us to use. So for our bottle feature that it displays the water temperature, so we began using the DS18B20 sensor, but the problems that we faced that it costed us more, and it also needed more wire connections. So for easier fit into our bottle, we shifted for the LPS22HP built-in sensor in order to reduce the size of the circuit. And the LPS22HP accuracy is plus or minus 1.5 degrees. So we tested the water temperature inside our bottle using the thermometer, and the reading was 27 degrees. Besides, our bottle reading temperature displays 28 degrees on our mobile app, which shows that the readings are within the error. And now Mohamed will talk about the water intake tracking feature.
Okay, so the next thing that we wanted to track was our users' water intake. And in order to do that, we needed to measure the volume of water inside the bottle. And so our very first approach was to incorporate a membrane at the bottom of the bottle and have a pressure sensor, the LPS22HB sensor, underneath it. And so it would sense any pressure when the membrane stretches due to the water on top of it. That idea didn't work because the sensor was too small and it didn't catch on any of the pressure applied by the water. So we need to find a solution for that. The solution was a pin method. Simply, we'd have a pin that consists of two parts. First, a flat surface area that would take all the pressure from the membrane, and then a pin underneath that would take all that pressure and apply it to the pressure sensor. That worked and it produced good results, but it had one problem. Because the pin was still too small, the sensor was still too small, any small change in alignment between the sensor and the pin, it would shift or change the results of the readings drastically. So we need to find an alternative instead. That alternative was the FSR, the sensor that you can see in the bottom image. It was more accurate, it was easier to fit, and it was more durable. It wasn't easily affected. The readings were really reliable and stable. Here, as you can see, we're measuring the accuracy, we're testing the accuracy of the FSR. We had 400 milliliters of water poured in our bottle. And as you can see, the readings are within the range of 400. Now, the next thing that we needed to do was to power up our bottle. And in order to do that, we have supplied it with a one lithium-ion battery. It was 3.7 volts with 220 milliampere hours. We also supplied it with a charger in order to help the users charge the bottle without having to remove the battery from the bottle itself. That gave us two advantages that made it appealing to the user. First, they wouldn't need to remove the charger the batteries from within. Second, they could charge the bottle while it remains operational, so it wouldn't have to go offline. As you can see, we had with the charger, it blinks a red LED in order to indicate that it's actually charging. In the first image, you can see that after using the battery for a while, it went down to 3.83 volts. And after charging it and leaving it to charge for a while, it went back to 3.9. Now, the system lifetime. We wanted to go for a system lifetime that is sensible to users. If you think about it, all the electronics surrounding us, they usually have a lifetime of 1 day and then you can recharge it. If you think about your phone, your iPods, your AirPods, and so on and so forth. So we wanted to opt for a 1 day system lifetime before recharging. We had to make a few assumptions in order to calculate that lifetime. First, the bottle will go on for a sleep mode for around 8 hours per day in which the user will be sleeping. And for the rest of the 16 hours, the user would be continuously executing all the operations, which would be the worst case scenario, but we wanted to account for it anyway. We also used the external oscillator, and we didn't use any memory on top any memory retention in the microcontroller. We offloaded it to the app in order to conserve power. And we found that 220 milliampere hours would give us 1 day lifetime. And now Eman will be explaining the system design, the bottle design.
Thank you, Mohamed. Oh, sorry. Okay, so as for the bottle design, okay, so we first intended to have the bottle to be all sealed, okay, made 100% out of stainless steel. But then we found out that stainless steel affects the odor and the taste of the water. That's why we came up with another design, which is having a detachable disc at the bottom. This is where all the circuitry will be placed. And the bottle walling will be made out of a BPA-free type of plastic called Triton. So it's as durable as stainless steel, but it's eco-friendly and doesn't affect the odor and the taste. Okay, so this is a close-up on the design of the bottle. This is a diagram showing how the circuitry will be placed in the detachable disc at the bottom. So there's a USB-C slot, which is directly connected to the charging board. And the charging board is connected to the battery. And this is where the microcontroller will be placed and directly connected to the FSR sensor, which will be directly in touch with the membrane so that it can sense any change in the volume. Can you go back? Okay, so okay, so since our design was very specific, we couldn't find something off the shelf that meets the requirements. So implementation of this bottle in real life has to be in molding, but since molding is outside the scope of this project, so we had to prototype to test the concept of the design in general. Okay, so these are the 3 prototypes that we created throughout the year. This was a very primitive prototype. One was a very primitive prototype just to test the concept of the design and will it work with the technology of the bottle or not. As for prototypes 2 and 3, they were manufactured. So the prototypes 2 and 3 were manufactured with a material called ortolon, which is very durable. This is yes, the prototypes 2 and 3 only had very few adjustments in between, just with the specifications and the dimensions, but they have the same design. There are 3 parts. The first part is the bottle walling. This is where the water is poured in, and the second and the third parts are representing the detachable disc at the bottom. This is where the circuitry are placed, and the membrane is placed on top. Now Salma will take you through the mobile application design.
Thank you. Okay, so I'm extremely excited to be presenting our iBottle app. So let me show you how it works. So basically, from a front-end point of view, our tech stack was using React Native as the cross-platform app development framework. We also used Overmind for the state management, and for testing, we used the iOS simulator and iPhone. And now I'll walk you through the app storyboard. So firstly, you log in using Google, and then if it's your first time logging in, you enter your information regarding like your weight and how much you train every day in order to calculate your optimal water intake per day. And then you scan to find your iBottle. And after that, you go on to the core of the app. So you basically view the homepage where you can see your water intake, the volume of water in the bottle right now, and its temperature. In the navigation tab, you can also navigate to the last paired location of your app in case you lose it. And also you can navigate to water dispensers around you in order to refill your bottle. In the history tab, you can view your water intake over the last week and last month. In the social tab, you can view your friends, and if they have public accounts, you can actually see how much water they've drank. You can also see their goals, etc. And lastly, in the settings tab, you can view your own information and log out as well. From a backend point of view, our tech stack was using Bluehost as our server and nginx as our server. Also, our database was using MySQL, and our RESTful APIs were written in PHP. And now I'll walk you through the app through a demo. Okay, so you log in. because it's the first time logging in, you enter your weight and daily workout in minutes. You also enter your privacy, whether you want your account to be public or private. And as you can see, the water intake is calculated, and then you set up. And here you can see it in real life, where I'm also going to be showing how the app actually pairs with the bottle. That's sitting right behind it. I scanned for devices, and then I selected our bottle. And then shortly, the readings will start showing up. So you can see the temperature reading on top, and the volume reading will show up under it. If you go back to the home page, you can also see all of this info live in front of you, changing all the time. So our volume reading is about 160, and then now we're adding more water to the bottle. And then you can see the volume reading, which is the second one, increasing as we pour more water in the bottle till it reaches around 200. Okay, and then we're gonna see the rest of the app features. So here I navigated to the last pair location in case I lost my bottle, which gets updated every 5 minutes as long as your app is still paired to the bottle. And also you can navigate to water dispensers using Google Maps very easily. In the history tab, you can view your water intake last week and last month in order to always make sure to improve. And here in the social tab, you can view your friends. So if I search for Shenawy, I can see his goal for today and the water intake so far. And you can also view like private accounts, but then you wouldn't be able to view their information because they're private. And also in the logout page, you view your info and log out. So overall, our final outcome is having a bottle, an app, and having them paired to each other. The app also notifies you to drink water in order to always stay hydrated. And the complete circuitry of the app is ready and working flawlessly. And now Hassan will walk us through the capstone reinforcement outcome.
So our product is a commercialized product. So its main objective is profit. So why we choose iBottle? First, it's the first locally manufactured smart bottle. Our app is user-friendly, as you just saw from Salma. The app is very easy to use and anyone can use it. And we want to motivate people to have a healthier lifestyle and drink more water generally. So this is a commercialized product, so we have a business canvas. First, we have our value proposition. First, we want to promote a healthier lifestyle. And we want to encourage people to drink water more regularly. Also, for our customer segment, we have dieters, athletes, elderly, and people who want to improve their water intake generally. As for our cost structure, we have 4 main cost structures. First, it's the manufacturing costs, the cost of the bottle itself. We have electronic components such as the sensors and microcontrollers. We have the shipping company fees, which is the company that will ship our products all over Egypt. And finally, we have the server subscription for our backend database. As for our revenues, we have also 2 main components, the price of the bottle itself, the delivery fees, and we want to integrate a store that will sell healthy stuff such as t-shirts and food, but we have to work on our key partners with them to have with other manufacturers. So our main competitive is the Hydra Spark X. It's another smart water bottle that's manufactured in the US, but we have 2 main components, 2 main advantages over them. First, it's the price. Our bottle comes in at $40, while theirs come in $60. And accessibility. You have to order the bottle from outside, and it takes at least 14 days. And right now it's harder to get due to economic reasons. Now you can, from Egypt, our bottle can be accessible at any local shop. Okay, these are references. Thank you. Do you have any questions?